Hello and welcome to this last video on representation of data for Probability and Statistics 1 paper in the A levels. We're going to take a look at the last method, that is the cumulative frequency graph. We have already seen the stem and leaf diagram and the histograms, and we're going to take a look at this graph in a minute. I just want to point out what we talk when we talk about cumulative frequency, because you may not all know this. So let's draw a small table of data. Imagine that we have a set of values x that have value a, b, and c with their corresponding frequency. So we have here, let's say that we have a 7, a 3, and then we have over here an 8. So what is cumulative frequency? Cumulative frequency is the values of the frequency up to that value that we are. So we're going to consider like previous values. So let's take a look at this. For the first value a, the only frequency we have so far is the one of a. So it's going to be 7 as well, because frequency up to that point is just a. So it's just 7. Now, when we move on to b, we're going to consider frequency up to this point. So in that case, we're going to be adding this 3 that we have here to the 7. 3 plus 7 gives us 10. And then for C, we're going to again add the values. We have 10 up to here, and now we're going to add 8 and end with 18. Why is this useful? Well, there are two things. One of them we're going to see in an example soon. But just to begin with, you can see that this value here at the very end of the cumulative frequency column will always tell you the total amount of data that we have. And that is very important for you to have, because if you have that value, then some things become easier later. So just to keep in mind. Two more things before we get into the diagram. First of all, if we're given data that is grouped, as we're going to see an example, we are always going to plot it against the upper boundary, and we're going to join the points using a curve. Okay, we call it a smooth curve. You will see that some people also draw the polygon, a cumulative frequency polygon. It's something that mathematically you can do, but for the A levels, it is highly recommended that it is actually expected for you to draw the curve. So always focus on drawing the curve. Okay, so how is this going to work? Let's take a look at the following example. We have here the table that shows length of 80 leaves from a particular tree, and just observe that, but just by reading at the task, you can see this given to the nearest centimeter. That means that values are rounded. So if you don't know what I'm talking about, take a look at my video on histograms, where I at the beginning I talk about what happened when data is rounded. When data is rounded, we must see that the classes that we're given here are not the actual classes. Just think about it in these terms. Imagine that we have, observe the classes. It's from 1 to 2, from 3 to 4, to 5 to 7, 8 to 9, and 10 to 11. What happens if a leaf has a length of 4.3 centimeters? That wouldn't fit within the category, because you have a gap of 4 and 5. So actually, the thing that's happening here is that the actual classes of this continuous data are not the classes that we're giving here. Actually, the class that is from 1 to 2 is actually for 0.5 up to 2.5. And then the class for 3 to 4 is from 2.5 up to 4.5. And then from 4.5 up to 7.5, from 7.5 up to 9.5, and then from 9.5 up to 11.5. So from there, if we're going to look at the upper boundary, that is what we want, because we're going to plot against the upper boundary, we must consider that the upper boundary for this one is 2.5, the upper boundary for this one is 5.5, then we have 7.5, then we have 9.5, and here we have 11.5. These are our upper boundaries. So from these upper boundaries, we're now going to construct the cumulative frequency. That is what we want, because we're going to plot cumulative frequency curve. So again, the first value is going to remain the same. It's going to be an 8. Then we're going to add 20, we're going to get a 28. Then we're going to add a 28 and it's going to give us 66. We're going to add 10, it's going to give us 76, and then we add 4 to get 80. Observe that hopefully I'm doing my math right, because as we had 80 leaves, we end up with the final value to be 80. If it were to happen that I wouldn't have gotten 80 here, I would have made a mistake probably with my additions. So good for me. Then we're going to plot this value. We're going to plot the value 2.5 with 8, 4.5 with 28, 7.5 with 66, 9.5 with 76, and 11.5 with 80. And the graph is going to look something like this. I have it here with the values drawn. Observe that I'm plotting the 0 here to the what would be the lower limit of our first class. Remember the first class that was from 1 to 0. It actually, sorry, the first class it was from 1 to 2, so the lower boundary would be 0.5. So at 0.5 I plotted the 0 there, and then all of the values with the points are marked, this point here, this one here, this one here, this one here, and then we have the curve along there. This curve, it has to be as smooth as you can. The idea is that you don't draw straight lines. You cannot do this, and this in the exam, like a draw and like a straight line. Just draw a smooth curve that will show data in that way. This is like the one the computer gives, so you can do it manually at your best count. And from this curve, we can get data. For example, let's take a look at this. We're going to consider that we can estimate, for example, the number of leaves that are less than 3.7 centimeters long. So how do we do this? Well, first of all, we're going to go to the graph and we're going to think, well, 3.7 centimeters is a measurement of length. So again, we go to the graph and we look at the value of 3.7. We have, this is 2 to 4. So this would be 3. So 3.7 would be somewhat around here. This will be our 3.7. So then I'm going to zoom in a bit so you can see more clearly. What we're going to be doing is we're going to draw a straight line right up to the curve there, that beautiful line, and then we're going to go all the way to here, and this would end up somewhere around that. This is not like strictly perfect, but we're making an estimation, and this works good enough to see that the value is going to be somewhere close to 20. I would say like 18 or something like that. In this case, the answer expected was 19. It was really close to that what we were expecting as an estimation. Probably there's something about the x's here that may have misled us a bit, but this is a very good estimation. Another estimation that we can do is call for the lower boundary for the longest 10 leaves. Okay, I'm going to look for which are the longest 10 leaves. I know that the longest 4 leaves that are here are between 9.5 and 11.5. Remember that this is not the actual classes. The actual classes is from 9.5 up to 11.5. But I want the longest 10, and if I include this, then I have 14. So let's try to see how we can use the diagram to find the longest 10. Well, think about it. If we're working with the longest 10, that means that we have a cumulative frequency up to 70. So let's try to see where we would find the 70 here in the diagram. Let's see, here we have 60 and 80. We have 2, 4, 5, 2, 4, 6, 8, 10. This here would be the mark that we're looking for. 2, 4, 6, 8 there. So we go to the graph and we cross it up around there. So that is almost like pretty neatly around the value over there of 8 centimeters. That is like a very good estimation for us, about around 80 centimeters to be our longest leaves. So now if we go and take a look at the expected solution, would be exactly 80 centimeters. It was a very good estimation for us to make. In these cases, when you're doing the exam, clearly that the answer that you are given is expected to be based on your graph. So focus on making your curve as smoothly as possible, and well, learn to read it like from one axis to the other. That's okay. In these cases, we're not going to be cortina the axes. because if we continue the axis, then it would make sense to have a frequency to begin that is not 0. So in general sense, that may not happen, although some lengths may, and that depends on how it will to work. But in general, you will see that that's not typical. But remember to do that if necessary. Remember to write the labels. The labels are really important in all of these diagrams. And well, this is everything for the graphs that we can use to show data until we get to measures of variation, and then we're going to include the box and whisker diagram. That's a very interesting one, but we're going to leave that for a further video. So remember that if you have any questions, you can comment on it. I will try to address them as soon as possible. And you also have the link to my webpage in the description where you can find more exercises with explanations on how to keep on working with these exams. So bye bye and thank you all for watching.